An involved question about the friction and acceleration of an object which is being pushed. Take a look and we'll get started. So you're being asked to calculate a couple of things here. One, you're being asked to calculate the coefficient of friction and also the acceleration of the object. Now on the first look at this one, I think I overcomplicated this for myself because there's lots of values and lots of bits of information. Actually, the question is quite simple once you get started. You're told, for example, that you have a 10 Newton force, and you're also told the resultant force is 6 newtons. So therefore, you should be able to put some stuff together here and solve this fairly quickly. Let's go for it. Let's use Newton's second law first. We're told the resultant force is 6, and we're told the mass is 2, and therefore we can get the acceleration very simply. 6 over 2 is equal to 3 meters per second squared. So we can rule out a couple of those options, the B and D there. Now, we also know that we have friction on a horizontal surface. I'm going to cram this all into one line here. Friction is mu times R. R here, the reaction force, is equal to mg, and so therefore the friction force is simply mu mg. Now, in order to calculate the coefficient of friction, we need to know the friction force. We know that because the resultant force is 6, the applied force is 10, and so therefore we must have a friction force of 4 acting on this body, and so therefore our frictional force mu mg is equal to 4. We know g is 10, we know the mass is 2, so it's a bit of a rearranging, and we end up with a 0.20 there, which gives our answer A. Now, this is one of the few questions where we get a bit of information from the examiner report. You notice in the question they mention something about sliding coefficient of friction rather than dynamic friction. Now you have to be familiar sometimes when you do these questions that they may use slightly different terminology. In this case, sliding. This may have been a mistake on the part of the makers of the question. It may have just been a slip, but it's something you do have to be aware of. Every now and again, even in exam questions, terminology gets mixed up. In this case, students weren't particularly bothered, but you may find that other times that there is a problem and it doesn't necessarily chime with what you're taught in lessons. That's why we try and use sometimes a bit of a variety of terminology when we're explaining physics concepts.